Hello students and friends, welcome to this course of rule based system. In the last lecture we discussed the concept of rule based system, and today we will discuss a new topic that is related to the rule based system. So, welcome to the enlightening discourse on rule based systems, which is forward chaining and backward chaining. As we embark on this intellectual journey, we will unravel the intricacies of two fundamental reasoning strategies that underpin the realm of artificial intelligence. So, in this lecture series, I, Dr. Samta Kajbie, will be shedding light on this distinct mechanism, applications and implications. So, today we are diving into the fascinating world of artificial intelligence, that is forward chaining and backward chaining. Now, this might sound a bit fancy, but they are actually super cool ways that computers think and help us solve tricky problems. So, let us break it down in a way that is easy to understand. Think of forward chaining and backward chaining like two secret strategies that computers use in something called expert system. Imagine these expert systems as super smart computer friends that are really good at solving puzzles. Okay, so here is the deal. Forward chaining is like when you start with some basic facts or clues and then keep adding more and more information until you figure out the answer. It's like building a chain of clues one after the other until you reach a solution. Imagine you are solving a mystery and every piece of evidence you find leads you closer to the solution. So, now let us talk about the backward chaining. This is a kind of the opposite. So, you start with the solution you want to find and then you work your way back to figure out the steps that lead to that solution. It is like starting at the end and tracing your steps backward to see how you got there. It is like solving a puzzle by looking at the final picture and figuring out how all these pieces fit together. But here is where it gets even cooler. We have this awesome computer system called expert systems that use these strategies. Imagine there is one system, that is expert system, that is MYCIN, acting like a medical detective. It uses backward chaining to diagnose infections. You tell it the symptoms and it works backward to find out what might be causing the problem. It is like solving a medical mystery. Another example of rule based system is the dendral, which is like chemical whiz. It uses forward chaining to put together the pieces of chemical puzzles. Starting with tiny building blocks, it adds them up step by step to create the whole structure of a chemical compound. It is like building the Lego bricks. Each step brings you closer to the finished creation. So, remember, forward chaining and backward chaining are like these cool thinking tricks that computers use to help us solve real life puzzles. Just like having a genius computer friend who loves solving mysteries and making cool discoveries. So, before moving to the details of forward chaining and backward chaining, let us first understand what is expert system. So, what is an expert system? It is a super duper clever software that uses special thing called a knowledge base. Imagine it as a brain filled with facts, rules and ideas ready to help us out. What's mind blowing is that these expert systems are designed to solve problems just like super smart human would. So, we are talking about complex problems in a specific field like medicine, chemistry or even engineering. So, it is like having a virtual expert who can think and solve problems at a higher level. And guess what? This system even learn human experts. They soak up their knowledge and put it in their brain. This knowledge base we have already studied in our previous lecture. So, this is what they can think and solve problems just like those experts. Now, here is where it gets even cooler, forward chaining and backward chaining. These are like the special tricks that expert system use to think and solve problems. Imagine forward chaining as a detective. It starts with the clues and adds more and more until it solves the mystery. So, backward chaining is like a problem solver. It starts with the answer and works backward to figure out the steps. But here is the amazing part. These tricks have become even more awesome. They have been combined to create a super power technique that is called the hybrid chaining. So, it is like taking the best of both worlds to solve the problems even better. So, as you can see in a block diagram, expert system have 5 important parts as you can see in the block diagram of expert system. One is the knowledge base. This can be imagined as the brain of the expert system. It is like a giant wallet filled with facts, rules and ideas about a specific topic. You know how we learn from books and teachers? Well, the knowledge base stores all that stuff and helps the system understand and solve the problem. Another component of expert system is the inference engine. This is like the detective of the squad. It takes the information from the knowledge base, analyzes it and figure out solutions to the problem. It is not just about finding answers though, it can also explain why it had made certain choices and even help fix things when they go wrong. Another component of expert system is the knowledge acquisition and learning module. Think of this as an expert system learning tool. Just like you keep learning new stuff, this module helps the system gather more information from different sources and adds it to the knowledge base. It is like giving our expert system a chance to keep getting smarter over time. Next component is the user interface. This is a friendly face to the expert system. It's like, and it can be understood as a translator, or it's like a translator between the super smart computer and us as a user. So, it lets us ask questions and get answers in a way we can understand. So, even if you are not an expert, you can still chat with the expert system and get the help from them. Next component is the explanation module. This is the storyteller of the squad. Once the expert system figures out the answers, this module helps explain how it got there. So, it is like giving you a summary of what happened and why that answer makes the sense. So, in general we can say that, so expert system use these 5 awesome parts to think, learn, talk to us and help solve problems. It is like having a team of brainy buddies right at your fingertips. The brainy part of the expert system uses 2 methods, backward chaining and forward chaining, to think and solve the problem. So, let us break it down. Forward chaining is, think of this as a detective mode. The inference engine starts with what it knows, like facts and rules from the knowledge base. It pieces them together one by one like solving a puzzle. As it adds more and more pieces, it reaches a cool solution and a smart decision. Coming to the backward chaining, this is once like a super problem solver. The inference engine starts with the end goal in a mind, like the answer it wants to find. Then it works backwards step by step to figure out what facts and rules led to that answer. It is like going from result, unraveling the journey that got us there. We will further look in a brief into the topic called the first order predicate logic. We are going to use a special tool called a truth table to understand better why we need now the first order predicate logic, because as we have seen in the rule based system, it uses the if then else conditions. So, first order predicate logic formalize that this if this condition and also the facts. Imagine you are solving a puzzles and you need to follow certain rules to get the right answer. That is what exactly what logical inferences does. it's like solving puzzles using the rules. We have two methods for this, backward chaining and the forward chaining. Now, let us jump into the example. Here P and Q are the variables that are used to represent these statements. So, not P or Q, do not worry if this symbol look like a bit puzzling, they are like puzzle pieces we need to put together. This is an example saying if it is not P or it is Q, then it is like saying P implies Q. Think of it as if I do not have an umbrella or I have a raincoat, then it is like saying if I have an umbrella, then I have a raincoat. Now, let us prove using our truth table. It is like testing all possible scenarios to see if our statement is true. Look at those T, that is true, and F, that is false. They are showing us if our statement works for different situations or not. Now, focus on last two columns. Our statement not P or Q is just like saying P implies Q. When P is true, that is T, and Q is true, that is T, the statement is also true. So, when P is true and Q is false, the statement is false. So, this is how computers use first order predicate logic with forward chaining and backward chaining to solve the complex problems step by step. So, now we will focus on to the topic, that is the forward chaining. So, now we will focus on to the topic, that is forward chaining. Forward chaining is like solving a puzzle. Imagine you have a bunch of puzzle pieces, that is facts and data, and picture on the box, that is goal. You start by picking up a piece, looking at its shape, which is a condition, and then finding where it fits in the puzzle. Gradually, you keep adding more pieces based on their shapes, and you keep doing this until you complete the puzzle and see the complete full picture, which is a goal. In forward chaining, we have a smart assistant called the inference engine. Let us look the step by step process. It begins with some pieces already placed on the puzzle board. These are the facts on the or data you already have. The inference engine starts looking at the facts, applies the rules to see if new pieces can be added. As the inference engine applies the rules, it might find certain pieces that can fit together, leading to new connections. These new connections are like adding facts or information. The inference engine keeps applying the rules, making new connections, adding more pieces to the puzzle. This process repeats over and over again. The inference engine continues this process until it reaches a point where it can't add any more pieces to the puzzle. At this stage, it has put together enough information to see the complete picture. This is the goal or the final decision that we want to achieve. So, as discussed in the previous slide, then dendral uses the forward chaining. We will use this example to understand the dendral system in a detail. So, to illustrate how forward chaining works, imagine you are a scientist trying to figure out the structure of different molecules. You have a data about the atoms and their connections, but you do not know the whole structure yet. You begin with some information about the atoms and their properties. Now, dendral has a set of rules that describes how atoms can be connected to form the molecules. These rules are like the instructions for the puzzle. So, dendral's inference engine starts applying this rule to the data you have. It figures out how atoms might be connected based on their properties and the rules. As the inference engine keeps applying the rules, it starts forming a molecular structure connecting atoms together in a meaningful way. Eventually, dendral reaches a point where it has built a complete molecular structure. This is the final decision or the goal. You now know how the atoms are connected in the molecule. In a nutshell, forward chaining is a method of reasoning in AI where we start with some initial data, keep adding more information based on rules until we reach the desired goal. Just like solving a puzzle, we gradually build up complete picture by connecting facts, making new inferences. General uses in predicting molecular structure showcases how powerful forward chaining can be used in solving the complex problem. So, this was the concept of forward chaining. We will see the properties of the forward chaining. So, again I have always been using this as an example for solving the puzzle. So, imagine you are solving the puzzle like connecting the dots to create a picture. Forward chaining is a bit like that. It is a way to reach a solution by connecting different pieces of information. Its properties include it uses the down up approach, that is bottom up approach. In forward chaining, you begin with the basic information you have, like the starting point of a story, and then you add more details on top of it step by step. The second property is using facts to make the conclusion. So, it starts from initial state and uses facts to make a conclusion, that is you start with what you know for sure, that is facts, and then piece them together to come to a conclusion. It is a data driven approach, that is you rely on the information you have in front of you. You use the facts you have collected to guide your journey towards finding an answer or a solution. Forward chaining is employed in expert system and the production rules, that is it is used in things like expert system which are like digital experts, and the production rule system which helps in making the decision in various fields. So, to sum it up, forward chaining is like building a tower of blocks starting from the bottom and adding more on the top, while solving a puzzle using facts to reach conclusion with the help of knowledgeable friend. Knowledgeable friend, who is the knowledgeable friend? That is the expert system and the production rule system, who guides you using the information you already have, that is the data driven approach. So, next we will see the example of the forward chaining. So, let us understand forward chaining through the example. Suppose we start with the given information, Tom is running, let us say A. Then another is we have a fact, if a person is running, he will sweat. So, he will sweat is B. This can be represented as A implies B, that is A forward arrow B. Using the forward chaining, we combine the given information and the fact to reach a conclusion, that is Tom is sweating, that is B. In other words, we know Tom is running, represented as A. We know that if a person is running, they will sweat, A implies B. Therefore, we can conclude that Tom is sweating, which is B. So, A is given, A implies B is given, we conclude B. This is the essence of forward chaining, starting with what we know, that is given information, using facts or rules to make conclusions and gradually build up our understanding step by step. We will see another example of forward chaining. So, the example is, as per the law, it is a crime for an American to sell weapons to hostile nations. Country A, an enemy of America, has some missiles and all the missiles were sold to it by Robert, who is an American citizen. We will walk through the conversion of given fact into first order definite clauses and then show how forward chaining can be applied to prove the conclusion, that is what is to prove that Robert is a criminal. Facts conversion into first order predicate logic. It is a crime for an American to sell weapons to hostile nation. So, FOP, it can be written in first order predicate logic as P is an American and Q is a weapon, and P sells Q to R and R is an hostile, implies that P is a criminal. So, this is in first order predicate logic. Another statement, country A has some missiles, which can be represented as there exists a P where A owns P and P is a missile. It can be written into two definite clauses by using existential instantiation, introducing new constant T1, that is A owns T1 and T1 is a missile. Another statement to be represented as all of the missiles were sold to country A by robot, which can be represented in FOPL as P is a missile and A owns P, implies that Robert sells P to A. So, another one, missiles are weapons, which can be represented as P is a missile, implies that P is a weapon. Next statement, enemy of America is known as hostile. So, in a first order predicate logic, P is an enemy of America, implies that P is a hostile. Next statement, country A is an enemy of America. In first order predicate logic, it can be represented as A is an enemy of America. Robert is an American, which is represented in FOPL as Robert in a bracket and American as the predicate. So, Robert is an American. Goal is to prove that Robert is a criminal, that is, which is represented in FOPL in a bracket Robert, which is a constant, and criminal is the predicate. Now, let us go through the steps with the explanation for each part in a forward chaining. Step number 1 is the fact selection. In this step, we start with the facts that are given to us. These are the pieces of information that we really have and do not need further reasoning or rules to understand. From the provided information, we identify the following facts. Robert is an American, A is an enemy to America, A owns T1 and T1 is a missile. These are the basic building blocks of our reasoning process. We will use these facts as a starting point or draw further conclusion using the rules. Coming to the step number 2, inferring from the new facts. Now, that we have our initial facts which we have represented in step number 1, we move on to the next step where we apply logical rules to infer new facts based on the information we have. So, rule number 1, as you can see in the rule number 1, this rule states that if an American sells a weapon to a hostile nation, they are considered criminal. However, for this rules to apply, we need specific conditions like owning a weapon and selling it to a hostile nation. Since we do not have this condition satisfied in our current facts, we can't add this rule in this iteration. Coming to let us see the rule number 2 and 3. These rules are about the ownership of missiles by country A. Since we have already established that country A owns some missiles from the given set of facts, we consider these rules as satisfied and add them. Next is the rule number 4. This rule states that if a country A owns missile and robot sells them to country A, then it can be inferred that robot is the seller. We can apply this rule since we know country A owns missile which is from rule number 2 and robot sell them to country A from the given facts. Now, by substituting P with T1 which represents the missiles owned by the country A, we can add the fact that sells is a predicate, in a parenthesis robot, another parameter T1, another parameter is A. So, it can be read as robot sells missile T1 to country A. Coming to the rule number 6, this rule connects an enemy of America to being hostile. Since we know that country A is an enemy of America from the given set of facts, we can apply this rule to infer that A is a hostile, that is country A is a hostile. Then step number 3 is reaching to the goal. In this third step of our forward chaining process, we are looking to see if we can satisfy the rule 1 using the facts we have, and in doing so reach our ultimate goal of proving that Robert is a criminal. Remember, the rule number 1 states that if an American sells weapons to the hostile nation, they are considered criminal. Now, we want to apply this rule to our current situation and check if the conditions of the rule match our available facts. So, let us break down the substitution. P is substituted by Robert, Q is substituted by T1, R is substituted by A, and hence we have the following facts. Robert is American, T1 is the missile, A is a hostile. Now, we substitute these values into rule number 1. After substitution, we get Robert is an American and T1 is the missile and T1 is the weapon. Robert sells missile T1 to A and A is a hostile, implies that Robert is the criminal. So, breaking it down step by step, we know that Robert is an American, we know that T1 is the missile, T1 is the weapon, we know that Robert sold missile T1 to the country A, we know that country A is hostile. By plugging these facts, we fulfill all the conditions of rule 1. As a result, we confidently add the conclusion that Robert is a criminal. This example demonstrates the power of the forward chaining approach in drawing new conclusions from the existing information. So, we have seen the various examples of forward chaining. Let us discuss the advantages of forward chaining. First one is it is about the efficiency. Forward chaining saves time by using known facts to find solutions, making it an efficient problem solving method. Another point is about the flexibility. It can handle different problems and be adjusted to suit various situations. Another advantage of forward chaining is real time decision making. Imagine quickly making decisions during a game. Forward chaining can help with a fast decision making because it uses existing facts to reach conclusions promptly. So, this was all about the disadvantage of forward chaining. Next, see let us look at the disadvantages of forward chaining. One point about the forward chaining is incomplete search. Like not exploring every corner of a room, forward chaining might not explore all possibilities, leading to a partial results or missed solution. Also, another disadvantage is lack of global view. Similar to focusing on one piece of a puzzle, forward chaining might miss the bigger picture, resulting in inaccurate conclusions due to not considering the whole context. Also, another point is difficulty with the conflicts. Forward chaining struggles with the situation where facts or rules clash or conflict. So, remember, forward chaining is like following clues to solve a puzzle. It is a powerful tool, but it also has its limitation. By understanding its properties and pros and cons, we can use it effectively to solve problems and making the decisions. So, this was all about the forward chaining. Coming to the another important topic, that is the backward chaining. So, this is like solving the puzzles in a backward way. Okay. So, you know how we talked about the forward chaining. When we start with what we know and use rules to figure out new things. Well, backward chaining is like flipping that idea around and solving problems in a different way. So, instead of starting from the clues and working towards the solution, you start with the solution, work backward to understand how all the clues fit together. In backward chaining, you start by knowing the end of the story, who did it or what happened. Then you look at the outcome and figure out all the little details and evidence that led to the conclusion. It is like knowing the end of the book and then reading through the chapters to see how everything in the story connected to create that ending. Think of backward chaining as being like a puzzle solver who starts with the finished puzzle and then takes it apart to see how each piece fits. You know what the final picture looks like and you want to understand the logical steps that were taken to make that picture. So, forward chaining is like solving puzzles and mysteries by understanding how things came together. So, let us see the example of backward chaining, solving Tom's sweating mystery. To solve, we will take the same example which we have taken for the forward chaining, that is Tom's sweating mystery. To solve a mystery about why Tom is sweating, we will use backward chaining to uncover the clues step by step. So, step number 1, that is the goal, which can be represented as B. So, our main goal, our mystery to solve is why Tom is sweating. So, sweating, which is B, is our end point, like reaching the treasure at the end of a treasure hunt. The facts, that is A implies B. We know that if a person is running, which is A, they will sweat, which is B. This is a fact we have. It is like knowing that if you eat ice cream, that is A, you might get brain freeze. So, we have this fact A implies B. The initial state is A. Now, we are wondering why Tom is sweating. How did we get to this point? Well, we need to go to backward, starting with what we know. We know that if a person is running, they will sweat. Backtracking and understanding the steps now. So, let us think, if we know that Tom was running, we did understand that based on the fact A implies B, he would start sweating. We start with the idea that if someone runs, they will sweat, A implies B, and we realize that since the Tom is running, he is sweating. Conclusion is, and there you have it. By using backward chaining, we have figured out mystery. Tom is sweating because we know that if someone is running, they will sweat. Based on the fact A implies B. So, what did we learn from this? Backward chaining is like working your way backward through a story to understand why something happened. In our example, we know that outcome Tom is sweating, and by using the fact A implies B and the initial state A, we connected the dots and solved the mystery. We use backward chaining to piece together logical steps and understand why behind the situation. So, this is one of the expert system based on backward chaining, MYCIN. MYCIN is a medical detective that helps doctor figure out what's wrong with the patient and suggest the right treatment. Let's see how MYCIN uses backward chaining to do this. MYCIN's goal is to figure out if the patient has a bacterial infection. That's like trying to solve a puzzle, and the answer is we are looking for is bacterial infection B. Step number 2 is clues and facts starting from the end, that is the backward chaining. MYCIN is a super smart. It knows that certain symptoms can point to a bacterial infection. For example, if the patient is vomiting, A, has diarrhea, let us say A, feels really sick in the stomach, let us say A, these are clues, that is facts that could suggest a bacterial infection. MYCIN stores these facts as A implies B, which means that if someone has these symptoms, that is A, it could lead to a bacterial infection B. Now, imagine MYCIN has a conversation with the patient. It asks about their symptoms and listen to their story. MYCIN collects all this information. So, MYCIN starts with goal, bacterial infection, works backward. It starts at the clues it has: vomiting, diarrhea, stomach upset, and it remembers the fact A implies B, that is, if there is a symptom A, that can lead to a bacterial infection B. When MYCIN sees that patient has vomiting, diarrhea, stomach upset, it follows the clues A implies B and says, aha, these symptoms match what could happen in a bacterial infection, that is B. So, finally, MYCIN is like the smartest puzzle solver ever. it now knows that patient might have bacterial infection because of these symptoms. It's like MYCIN solved a medical mystery. And you know what? MYCIN doesn't stop there. It's not just a detective, it's also like a wise advisor. It knows what kind of treatment matches different bacterial infections. So, based on its diagnosis, MYCIN suggests the right treatment, like using ciprofloxacin. It is like giving the patient the perfect medicine to get better. In a nutshell, MYCIN, which is our AI detective friend, uses backward chaining to solve medical puzzles. It starts with goal of figuring out if the patient has bacterial infection. Then it looks at the patient's symptoms, uses facts it knows and works backward to connect the dots. Finally, it diagnoses the problem and suggests the right treatment. It is like a medical superhero that uses its brain to help doctors help patient. Remember, just like you did solve a puzzle by putting the pieces together, MYCIN solves medical puzzles by connecting the clues and using the backward chaining. Now, let us see the example of backward chaining using first order predicate logic. Sure, let us go through the example using backward chaining to prove that Robert is a criminal. We will work step by step just like we did with the forward chaining, but this time we will start with the goal and work backward to see how it is supported by rules and the facts. So, the goal is to prove that Robert is a criminal. So, we want to prove that Robert is a criminal based on the rules and facts provided. Let us see how we can use backward chaining to do this. So, in step number 1, start from the goal. Our goal is to prove Robert is a criminal. We need to find evidence that supports this conclusion. Using the rules to connect the dots, let us look at the rule number 1. If someone is an American, has a weapon, sells it to a hostile nation and sale is if someone is an American, let's look at the rule number 1. If someone is an American, has a weapon, sells it to a hostile nation, then they are criminal. Okay. So, we want to prove that Robert is a criminal, and guess what? This rule has something that matches our goal. P is a criminal, let us use P as a variable, but instead of P we put here Robert. So, Robert is a criminal. So, using this rule we get Robert is an American, substituted P as a Robert, Q is a weapon, Robert sells Q to R, R is a hostile, and this implies Robert is a criminal, but we have not substituted Q and R. We have not got any substitutions for Q and R. So, we will move further. We know that Robert is an American, that is fact we have got. We also know that Q is a weapon, even though we have not figured out what Q is exactly. There is something about Robert selling something to a hostile nation, but we do not know who is the hostile nation and what is the Q. Finding more clues. In step number 3, we will be finding more clues for Q. So, we have got a clue that says Robert might have sold something. Robert sells Q to R, and this could be related to being a criminal. But what did he sell? Well, we know that Q is a missile, is connected to a weapon, that is Q, because of rule 5, that is P is a missile and P is a weapon. So, using this connection we figure out that Robert might have sold a missile, because we know weapons can be missiles. So, coming to step number 4, we know that Robert sold something to country A. So, we will substitute instead of P, T1. So, P is substituted by T1, and we have rule 4, which says that P is a missile and A owns P, implies that Robert sells P to A. This rule says that if missiles are owned by country A and Robert sells them to country A, then Robert is a seller. So, using rule 4 we can say T1 is a missile, is owned by country A. So, A owns T1, Robert sold missile, that is T1, to country A. So, Robert sells missile T1 to country A, connecting the dots, getting closer to our goal. We now know that Robert sold a missile T1 to country A, and this fits with rule 4. It is like finding more clues that let us closer to the truth. So, in step number 5, we will get collecting more clues. Remembering, we are using the rules and clues to prove that Robert is a criminal. In step 4, we discovered that Robert sold a missile to country. Now, in step 5, we have a new piece of information. We know that country A is an enemy of America, and we also know that enemies can be hostile. So, connecting this, guess what? We have rule 6 which says that P is an enemy of America implies that P is a hostile. This rule tells us that if something is an enemy of America, it is also hostile, and if we just found out that country A is an enemy of America, so we can apply rule 6 and say that country A is also hostile. So, bringing it all together, we have now a bigger picture. We have connected the dots, used the rules to show that country A, where Robert sold the missile, is a hostile, and remember that this also means that country A is an enemy of America, just like rule 6 tells us. So, the conclusion is Robert is a criminal. So, this was all about the examples of forward chaining, which we have used the same example for the backward chaining and for the forward chaining. Coming to the properties of backward chaining, it is known as the top down approach. Think of this like starting from top of the puzzle and working your way down. You have the final picture in your mind and you are figuring out how all the pieces fit together to create that picture. So, another property is it uses the modus ponens inference rule. It is like a rule of logic that says if something is true and I know it is true, then I can use that to figure out more things that are true. In a backward chaining, the goal is broken into sub goals or sub goal to prove the facts true. In a backward chaining, you start with a big goal you want to prove, but that goal might be too big to solve all at once, like solving a huge puzzle in one go. So, you break it into smaller parts like solving different sections of the puzzle. Another property is it is called a goal driven approach, as a list of goals decides which rules are selected and used. So, just like you are driven to finish solving the puzzle, backward chaining is driven by a list of smaller goals. You focus on the smaller goals to figure out how to reach your big goal. It is like breaking down a big problem into manageable steps. So, backward chaining algorithm is used in game theory, automated theorem proving tools, inference engines, proof assistants and various AI applications. So, it is a method that mostly used a depth first search strategy for proof. Okay, so, now let us think about how you solve a maze. You go as deep as you can down one path before trying another path. Backward chaining works a bit like that. It focuses on exploring one possibility really well before moving on to the other. The modus ponens inference rule is used as the basis of backward chaining. This rule states that if both the conditional statement P implies Q and the antecedent P are true, then we can infer the subsequent Q. Forward arrow, after the forward arrow Q is known as subsequent, and before the forward arrow P is known as antecedent. In a nutshell, so backward chaining is like a smart puzzle solver but instead of just putting pieces together, you are also using special rules to make decision. You start with the big picture you want to prove, break it into smaller steps and use logic to connect the dots and find out what's true. Next we will discuss the advantages of backward chaining. So, in a backward chaining, the result is already known to you. So, it is like working backward from that answer to find all the clues that led to it. It is like solving a puzzle when you know what the picture looks like. It is a quicker method of reasoning than forward chaining, because the end point is available to us. So, backward chaining is like being a super fast puzzle solver. Why? Because you start with the solution, the end point, and then you figure out the steps that you got there. It is like solving a maze when you already know where the exit is. You can find your way out really quickly. In this type of chaining, correct solutions can be delivered effectively if predetermined rules are met by the inference engine. Think of the backward chaining like a game with rules. You can have a set of rules like a recipe that tell you how things work. If you follow these rules, you can find the solution. If anything has advantages, it has disadvantages too. So, coming to the limitations of backward chaining, even though the backward chaining is pretty cool, it has few limitations. Imagine you are a detective trying to solve a mystery, but you need a clue to start. Backward chaining is a bit like that. You need to know the final answer, the end point, before you can start working backward. This is what the disadvantage, that you should know the final answer or the goal. It is like trying to solve a puzzle when you already know what the picture looks like. Another disadvantage of backward chaining is it does not deduce multiple solutions or the answer. It is great for finding that one correct answer, but if there is more than one solution, backward chaining might not explore all the different possibilities. Then the third disadvantage is it only derives data that is needed, which makes it less flexible than the forward chaining. In a nutshell, forward chaining knows the solution and works backward to find the clues. It is quick, efficient and follows a set of rules, but it is not great at exploring different options or figuring out if you do not know the answer in the beginning. So, throughout this lecture, we have discussed the backward chaining and forward chaining, its concept, the advantages, properties and the various examples. So, let us sum up things and compare backward and forward chaining in a way that is easy for you to understand. So, backward chaining and forward chaining are important methods of reasoning in AI. These concepts differ mainly in terms of approach, strategy, technique, speed and the operational direction. Forward chaining is important to the developers that want to use data driven algorithms to develop effective computer based system. Backward chaining is important to the developers that are interested in using goal driven algorithm to design effective solutions in complex database system. So, that is all for this lecture. In the next lecture, we will see another topic, how to handle the uncertainty. That is all. Thank you.